Hi guys, this is your 1.2 solving systems of linear equations by substitution. We're going to go through one of your homework problems together and kind of get some more practice with this. So we want to solve specifically by using substitution, right? So just some stuff that we can remember here is that substitution means to replace or plug in. And remember, a solution is what the two equations or lines have in common. Not just what they have in common, but what coordinate or point the two equations or lines have in common. So where do they overlap? Do they intersect? Right? Is it, remember, three different types? We could have one solution, they cross the intersect at one point. We can have no solution, the tragic love story. They're parallel lines, they will never meet, right? Or infinitely many, it's the same line copied and pasted. So what coordinate do they share? Every single coordinate, all right? So we want to solve specifically by using substitution. How do we do that? So remember, when we're substituting, we're replacing, we're plugging in. We see we've got two equations, and they're telling us in equation 2, hey, y equals all of this. They're saying, hey, y equals all of that. And we're like, thank you, because if y equals all of that, we can replace, substitute, plug it into our first equation. And again, I know some of us are like, ew, I don't want to color code, I don't want to show this work. We got to show all of our steps, show all of our work, taking it nice and slow, especially with substitution, because right, we don't want to make a minor mistake. When we make that minor mistake, especially at the start, everything's gonna be wrong. So we want to go nice and slow, take our time. All right, what are they giving us? How am I plugging this in? What am I substituting? All right, we're gonna go ahead and rewrite equation number 1. But now instead of y, we're replacing it with what y equaled from equation 2. It's gonna make sense when we see this. So 5x minus 7, super crucial, we gotta remember those parentheses and plug it in, negative x plus 2, and parenthesis equals 58. All right, so again, where did this come from, right? All we did was replace y from equation 1 with what y equals from equation 2. And now it's maybe still looking a little rough, but you know, we can do this. We've seen worse problems for multi-step. So how do we work this out? We're going to start by distributing the 7 to both terms, and then we'll rewrite from the left of the equation. So 5x minus negative 7 multiplied by negative x, double negative, positive 7x. Negative 7 times positive 2 is going to be negative 14 equals 58. We're going to clean this up, move some stuff over, right? Grouping like terms. In the same step, I'm also going to add 14, right? We'll double check. So 58 plus 14 is going to be 72. I know, me and my mental math. I always got to check, just want to make sure. 7 and 5, so 7, 8, 9, 10, 11, 12. 12x. We want to get x by itself, so we're going to undo this coefficient of multiplying, reverse it with inverse with, division. And then I just checked that was x equals positive 6, right? But remember, we're not done. I know some of us are like, hooray, we solved for x, but that wasn't quite our goal, right? Where they overlap, it's going to be a coordinate. What do we know about coordinates? It's going to have an x and a y value. So our final answer is going to be x comma y, right? X comma y. The x value is going to be 6, but right, that doesn't quite narrow it down. When x equals 6, that's, there's a lot of possible answers there. So we got to pinpoint where specifically are they overlapping? Where are they crossing over, intersecting? All right, so what do we do with this information? We're going to plug it in. It doesn't matter which equation you plug it into. You'll get the same answer, right? But for our class, and it's just in life, why make things more complicated than it needs to be? Equation number 2 is looking pretty nice because, first of all, it's looking smaller numbers, and they already have it set up y equals, and we want to know what y equals. So we're going to use equation number 2, negative x plus 2, color coding, but now instead of x, we're going to replace it with positive 6. So we're going to plug it in. We'll rewrite this and show her how that looks now. Y equals negative parenthesis 6 plus 2. I know some of us are like, even then we got to include the parenthesis. Yes, we want to get in the habit of always showing parentheses when we're plugging something in, especially if it's a binomial like this guy, because it's reminding us that we have to distribute. I know. Some of us are like, we don't want to do the extra steps, but this is gonna save us in the future. Just remember, get in the habit, whenever we're plugging something in, always include those parentheses. All right, we multiply. Negative 6 plus 2 is going to be negative 4. Y equals negative 4. And I know, it's like, oh my gosh, this problem was never ending. It was so long. Let's check and see. This is a good place to pause too while you're working on your own problems. Just put that out there. All right, we move on. X is positive 6. Y is negative 4. All right, just double checking. Yep, looks good. We got it. All right, go ahead and continue the rest on your own. Like I said earlier, pause at that earlier point where we had all of our notes and the work shown. So you can have that up for reference while you finish it up. As always, any questions, email, text, let me know. Good luck, guys.